Okay, so I'm going to try this again. I had this whole screencast done and I deleted it by mistake. So here we go. Anyway, this is a great question, and what they are asking you for, a great question to review, is you're given a mixture of that solid, and how would you separate them? So they are both white crystalline solids and they're ionic, so they're solids at room temperature. So they're just telling you various reactions. Reaction one, you react the solids with water and you end up with bases, right, which is what we talked about. They are both solids, so they don't dissolve in water. So if you were trying to separate them and you just added water and then, say, tried to filter them, nothing would happen because both of the solids would be on the filter paper. So that's actually an answer to one of the questions down here. So let me just go ahead and jump to that question. So it says students are asked to develop a plan for separating those two components. One student proposes that Al2O3 can be separated from the mixture by adding water and then filtering. Explain why this approach isn't reasonable. So I just did, again, because they're both going to be on the filter paper, because nothing happens. Okay, the other part of the question, actually, I do want to review one thing which is related to a portion of the question, and that is lattice energy. So you guys don't have to be able to crunch numbers with this equation, but I just want to review again. Lattice energy is the energy of like the lattice of a crystalline solid. So like NaCl has a certain amount of energy, right, within the bonds, MgCl2. So lattice energy is a constant times the Q1, which says the cation, the positive ion, and Q2, which would be the negative ion. The greater the absolute value of these two multiplied together, the greater the lattice energy. So lattice energy depends upon charge, how big, again, in absolute value the charges are. So for example, for Fe and Al, they both have a charge of +3 in those compounds. And then oxygen has a charge of -2. So that's a pretty solid lattice energy there. But for example, say instead of oxygen it was reacted with like fluorine, then that would be a -1. Fluorine is a -1. It gains 1 electron. So that would be a lesser lattice energy, so weaker. Okay, the other thing that lattice energy has to do with is the size of the ion. So if the ion is smaller, the lattice energy is greater because of more Coulombic attraction, nuclear charge closer to the valence electrons. If the ion is greater, the lattice energy is less. And that's represented by R, which is the radius. So Q1 we'll say is the charge of the positive, Q2 is the charge of the negative, and R is the radius of the ion. So that's the formula. So again, the greater the radius, the lower the lattice energy. Okay, so now back to the question, how are we going to separate those two solids? So the question down here is, they're saying, all right, given all these equations, how would I start? And they gave you a starting point. So they said, what we're going to do is we're going to add NaOH to this mixture. We're going to convert that into that and then to that. Okay, now what the heck are they talking about? So what they're going to do is they are going to add NaOH, which is a base and it's aqueous, to the whole mixture. And when they add NaOH to the whole mixture, you can see that when you add NaOH, there's no reaction with FeOH3. So let me just kind of get back to that. So NaOH, they're going to add it to Al2O3 solid plus, because the other stuff is in there too, Fe2O3 solid. So you're like, okay, well that equation isn't directly up there, right? But what they're saying is, see how NaCl is aqueous? Right there. So you can assume that these two components are going to react with the water first, at some point, and then they're going to react with the NaOH. So we can go right from this equation to these two equations up here. So first, again, the aqueous part is going to form that solid and then that solid. So once we have those two solids, and then the NaOH is going to be reacted. With the first one, there's going to be no reaction. So it's just going to be a solid, right? So we can filter that out. So what they have here is they're going to react that, and then they're going to produce this NaAlOH. I hope I'm not making you dizzy with this. And you have that as an aqueous form. So that's going to be aqueous. The other part is going to be a solid, so you can filter out the solid, and you got rid of that. The problem is now we're left with this component right here. So we got to do something with that. So looking back on the equations, because ultimately what we want to get to is this. So going back to the equations, I'm going to find NaAlOH4, which is here. And it says when you add acid, it's going to turn into this, which is a solid, NaClAq, which is dissolved, and liquid water. So looking at this right here, you can say, oh wow, I can filter out the AlOH3 because it's a solid, and the other ones are going to go right through the filter paper. So step 3 would be react that with HCl. And that's, I don't know what that says, but that should be AQ. So that reaction right there is reaction number 7. So you would write 7. Okay, so now after that reaction, I filtered it, right? So I am left with this, just this. And I look down at these equations. This one I don't even care about. And I have a solid, so if I heat it strongly, I'm going to be left with a solid, which is what I want, and water vapor. So if I heat something strongly, the water vapor is just going to evaporate into the air anyway. So after I filter the AlOH3, then I can strongly heat the Al2O3. The water is going to evaporate, and I'm going to be left with that. So that is reaction number 9. So hopefully that helped, and you didn't get too dizzy trying to follow along. This is the 2015 International Free Response. So if you look that up, you should be able to find this question and look at it more directly. Have a great day.